Hi, and welcome to the DroPro segment on installing a magnetic digital readout kit onto a lathe. This video is the second of a four-part series and shows you how to install a magnetic scale onto the cross slide or x-axis of your lathe. Now, if you haven't seen the previous video, I would suggest watching it now because each video builds on the previous segment's material. All right, so let's get back to the lathe and install the x-axis scale. Okay, so now that we've seen all of what's in the box, let's start by taking a look at how we're going to install the kit. We'll start with the cross slide. And here's the scale. So let's hold it up against the cross slide and see how it looks. Now, we can see it would probably mount just fine, although it does seem to hang off the end just a little bit, maybe about 1/4 of an inch at most at the front. No doubt we could make this work as is, and it would probably be fine, but in the interest of making a more comprehensive video, we're going to shorten it a little bit and make it fit just perfectly. Now, of course, if your scale fits and doesn't hang over the end, there's really no reason to cut them any shorter. It's just that in this video, we want to show how to cut the scales. Okay, so how do we do this? We first need to go to the library page on the DroPro's website and download the Cutting Scales Worksheet 2-axis lathe. This is what the worksheet looks like. Now, the first item it asks for is the x-axis travel, meaning the full travel of the cross slide. We already measured this earlier, so let's fill in 6.5 inches as the x-axis travel. Next, we need to find max length. This is the total length of the table. And it looks like it's 13 3/8 inches long, so we'll fill that in next. Moving down the worksheet, our x-axis travel is 6.5 inches, so we'll need to add 4 inches to that, which means x-min is 10.5 inches. The next line calculates x-max. From above, our max length is 13 3/8 inches, so we'll subtract 3/4 of an inch from that, which means x-max is 12 5/8 inches long. Well, that finishes the cross slide math, so now we need to prep the scale. First, we transcribe the hash marks from the stainless steel strip over to the shoulder of the scale. Next, remove the cap screws from the opposite end of the scale, take the end cap off, and then slide out the stainless steel strip, like this. And now we mark the scale according to the worksheet. Notice that we're marking these distances from the cap end of the scale here to include the cap length itself. This is important. And one other point, on our library page we have a document called How to Cut Magnetic Scales, which covers all of this in a lot more detail. And of course, if you ever get stuck, you can always call us at DroPros. Remember, you're the customer and we're here to help. Okay, so the shortest we want to cut the scale is x-min, which we calculated to be 10.5 inches. Let's mark that in red. And the longest we want at the scale, X max, is 12 5/8 inches. Let's go ahead and mark that in green. So here we've got the marked scale. The shortest we want to cut the scale is marked in red, the longest is in green. Now anywhere between the two marks is fine, but DroPros always recommends cutting longer over cutting shorter. Remember, you can always cut it again if it's too long, but if you cut it too short, you can't make it any longer. Now an important point to remember is to never cut a scale shorter than the red mark or X min. In most cases like ours, the red mark is shorter than the green mark, but it is possible to have these marks reversed on some smaller lathes. Again, the bottom line to remember is to never cut a scale shorter than the red mark. So now we're ready for the fun part, cutting the scale. Well, here's our number 3 best kept secret of mounting digital readouts, introducing the Diablo non-ferrous metal chop saw blade. Now previously we only recommended using expensive diamond tip blades that cost hundreds of dollars, but trust us, this Diablo blade is a real winner. This one cost only 59 bucks at Home Depot, and the finish it leaves is incredible. Okay, so let's cut. So now we can start to reassemble the scale. The first thing we need to do is to reinsert the stainless steel strip, making sure to insert the hash mark end first so that the hash marks line up with the scale. Next, we'll mark the end of the stainless steel strip where we need to cut it. Slide it out a bit, and then trim it off. Slide it back in, and then test fit the end cap. Finally, the holes for the end cap screws are already there because the holes are actually preformed grooves or slots that run the entire length of the scale body. All we really need to do now is simply tap the hole, and to do that we'll use an M3 by 0.5 plug tap. So with that done, we'll put the stainless steel strip back in and then bolt on the end caps. And here's our finished scale. Now before we mount the scale, we need to take a look at where the reed head bracket is going to fit. The reed head rides on top of the scale and is bracketed from the saddle below using this bracket. Let's take a look at how that's going to fit on our lathe. Now on most lathes, the surfaces where the scale mounts and the bracket mounts are in the same plane. But on this lathe, as you can see here, the surface where the reed head bracket mounts is higher than the surface where the scale mounts. The reed head bracket that comes in the kit is designed to fit a standard mounting scenario where both mounting surfaces are in the same plane. So what we need to do here is to shorten the height of the reed head bracket. Specifically, we need to cut the mounting bracket short by at least the height of the shoulder here on the lathe. So let's go ahead and measure that. Now it looks like the distance between the top of the shoulder and the side of the cross slide is 6.5 millimeters. So all we have to do is shorten the mounting bracket by at least this distance and we'll be good to go. Now, one last consideration. There are 4 grub screws on the base of this bracket that extend out and not only level the bracket, but also adjust the height to properly space the reed head from the scale. In other words, it's probably a good idea to cut the bracket just a little bit shorter and give the grub screws a little more room to work with. I think shortening the bracket by about 7 millimeters should work well. So here we have our modified reed head bracket. Let's go ahead and test fit the scale. But first, I need to temporarily hold the scale and the reed head in place. But how do I do that? Well, here's our number 2 best kept secret of mounting digital readouts. Introducing Scotch brand double-sided outdoor mounting tape. Now, don't let this stuff fool you. This tape is seriously heavy duty and you're warned ahead of time not to use too much. Okay, so I'll apply 2 1-inch strips to the back of the scale. And then stick the cross slide scale right here where I want it. Next, we need to figure out where we're going to mount the reed head bracket. I'll start by putting some tape on the bottom of the bracket. And then place the bracket on the saddle below the cross slide scale. Now, because there's not a lot of room between the saddle and the scale, you can see how the reed head bracket sticks up too high. In other words, the bracket, as it is, would place the reed head well above the scale, like this. So what we need to do now is to shave down this top surface that sits flush against the reed head. Let's go ahead and measure that. And it looks like we need to shorten the height of the bracket by about 14 millimeters. Okay, back to the mill. Okay, so here we have the modified reed head bracket, and you can see that we've taken 7 millimeters off the side of the bracket, and we've also removed 14 millimeters off the top of the bracket. So let's give it another test fitting. However, first we want to mount the reed head to the top of the bracket using the longer 4 millimeter screws from before. I'll apply some more tape to the side of our bracket. And that looks pretty good right there. Looks like everything's going to fit pretty well. So let's go ahead and run the cross slide back and forth and make sure the reed head doesn't hit the end of the scale with the cross slide all the way to the front or the back. And as you can see right here, as we move the cross slide all the way to the rearmost position, the wiper on the reed head is getting close to the end of the scale. In fact, if I continued here, it would basically run into the end of the scale. Well, we don't want that to happen. So what that's indicative of is that we've mounted the reed head too far to the front of the machine, and what I need to do is I need to remount this reed head further to the rear of the machine. And again, that's why we use double stick tape to start with. Certainly better to find out now than later. So the solution here is to remount the reed head bracket further to the rear of the saddle. So let's go ahead and do that. Now this time what I'm doing is I'm moving the cross slide all the way to the far rearmost position, and then I'm going to place the reed head in position, and that way I know for sure that the reed head is not going to run into the end of the scale. But let's go ahead and try the other direction just to make sure. Okay, so with the cross slide all the way to the frontmost position, we can see that there's still a gap between the reed head and the end of the scale. And that's what we want. And that's a real advantage of using this double stick tape, is it allows us to recheck the clearances, and specifically, we want to make sure that we mount the reed head in such a position that it doesn't run into the ends of the scale when either the cross slide is at the full forward position or the most rearmost position. And using this double stick tape allows us to move everything around and check the clearances and not have to re-drill holes in our machine. Okay, so let's give that one more shot. Let's go ahead and give it one more time and move the cross slide all the way to the rear and make sure that we still have clearance, and that's a good place to put that reed head bracket. And there we go. You can see that there's a gap between the end of the scale and the reed head wiper, and that's what we want. We want to have a gap on either end of the scale when the cross slide is either at the full rearmost or the most front position. We don't run into the end of the scale and we don't damage our equipment. Okay, so that looks real good. So let's mount it for real now. But the problem is, how do we drill our holes? You can see how we don't have a lot of access room to get our drill into. Well, it used to be that oftentimes we'd have to remove the entire carriage from the lathe, disassemble the slides, and then drill the holes. But not anymore. Introducing our #1 best kept secret for mounting digital readouts, drill extensions. And here it is. We simply insert this into our drill and then put the drill bit into the end of the collet and then tighten it all down. Very simple to use, and by using these, we can get into the tightest corners of any digital readout installation. The time and work they've saved us is simply amazing. A definite must-have for installations and our #1 tip for getting the job done right. Now, the first step is to drill the pilot holes for the scale. The end caps on the scale mount using an M4 by 0.7 millimeter socket head cap screw. So for mounting the scale, we'll have to first drill 2 3.3 millimeter pilot holes. Now for the reed head mounting bracket, it uses M6 screws, which require 5 millimeter pilot holes. Okay, so let's drill those holes. so with all of our holes drilled out, now we need to start tapping. Let's remove the scale and the reed head bracket for a little bit better access. So let's start with the cross slide. Now we've drilled what's called a blind hole, meaning the hole does not pass all the way through the material. This is important because it affects the type of tap we need to use. Today we'll be using two different types of taps. First we'll be using a plug tap, and second we'll finish the hole with a bottom tap. Let's go ahead and take a look at these. Now if you look closely at the tap end, you can see a plug tap is tapered at the end, where the bottom tap is square and is not nearly as tapered towards the end. This is because the bottom tap is threaded almost all the way to the end because it's designed to tap the very bottom threads of a hole. The taper on a plug tap is important because it does two things. First, because the thread is tapered and gradual, it's easier to start threads with. But perhaps more importantly, because of its taper, it's also easier to control what angle the threads first start at. Now this is extremely important when starting to tap. It's imperative to make sure the tap starts threading at exactly the same angle as you drilled your pilot hole. Having a tap break because it didn't go in the same angle as your hole is not a fun experience. And finally, when you're tapping, take your time. Go in until you feel the tap start to clog with chips and then back it out to clear it. Okay, so let's start with our M4 by 0.7 plug tap, and we'll keep tapping until we can feel it hit the bottom of the hole. Now, one other item the producer wants me to mention is that due to the tight distances and the angles that the cameras use while filming these tutorials, it sometimes makes it look like we're angled and we're not drilling or tapping straight into the machine. Now, just off to the left and out of camera range here, I've got a feedback monitor pointed straight towards me, and it does appear like we're slightly angled going into the cross slide. I assure you this is going in perfectly straight and we're not at all angled even a slight bit. All right, so now we'll tap the other end of the scale. And now that the initial threading on the end caps is complete, we'll finish the end cap holes with the M4 by 0.7 bottom tap. And again, you can see it's different from the plug tap because it has threads almost all the way to the bottom. And as expected, this is initially going in nice and easy. The only threads it's really going to be tapping will be those towards the bottom of the hole. Okay, so now that we've finished tapping both holes for mounting the scale, let's tap the holes for the reed head bracket. We'll start by tapping both holes with the M6 by 1.0 plug tap, with one minor modification. We'll be removing the traditional T-handle off the top and instead use a socket extension like this. And the reason is because we don't have a lot of room or access between the ways of the lathe. And next, we'll finish both holes off with the M6 by 1.0 bottom tap. Okay, so now that the holes are drilled and tapped, let's go ahead and mount the scale and the reed head. But first, in order for the reed head to read correctly, we need to make sure that the hash marks on the scale and the hash marks on the reed head end up on the same side when they're both mounted. Let's have a look at the reed head. So you can see here on the bottom of the reed head that there's a set of hash marks. And also on the scale, there's a corresponding set of hash marks. Okay, so let's take everything over to the lathe and have a look at our setup. Now, the first priority that I want to think about is which way is the cable being routed. Now, taking a look at the cross slide, you can see that the reed head will be oriented like this, and we obviously want the cable going to the rear. Now, with that said, the hash marks on the reed head will be on the underside. So what we want to do is when we mount the scale, we want the hash marks to be on the bottom of the scale to correspond with what's on the reed head. And as you can see here, this would not work because the hash marks are on the top of the scale. Well, the solution is simply to rotate or swap the scale end for end, which now puts the hash marks on the bottom side of the scale, and that of course corresponds with the reed head where the hash marks are also on the bottom side. Okay, so now that we've figured out the orientation of how everything fits together, let's go ahead and mount it. We'll start with the scale, which mounts using the M4 by 15 millimeter socket head cap screws. Next, we'll install the reed head support bracket, which installs using the 6mm socket head cap screws. Now, one thing to not forget is before you install the reed head support bracket, make sure to install the 4 grub screws that help level the bracket first. And finally, we'll mount the reed head using the M4 by 20mm socket head cap screws. Now, you may have noticed that when installing the scale, all I did was really visually line up the top of the scale with the top of the cross slide. So to make sure that everything gets really dialed in, next I'm going to set up my dial indicator on the saddle and rest the tip of the dial indicator on the top shoulder of the scale. Okay, so now that the dial indicator is ready, I'll simply run the cross slide back and forth and adjust the ends of the scale either up or down until the dial indicator zeroes out. All right, so over the course of running the cross slide to the front, you can see that we've lost a little bit, that it's lowered a little bit on the right-hand side. So at this point, what I'm going to do is simply raise the right end of the scale. All right, so I've raised the right end of the scale so that the dial indicator now indicates 0. So I'll try again just to check my results. I'll run the cross slide back and forth once more. All right, and I'm not sure exactly how I got that lucky, but we've literally got 0 deflection there. So we've adjusted the end of the scale. It is within specs, and we'll move on. So next, we need to set the distance between the reed head and the scale. Let's go back to our bench for a moment. We're looking for the clear plastic shim, and remember, it's fairly easy to miss. And here it is. Now, a great technique we've heard back from our customers is to write the word shim on it so it's not quite so easy to lose. All right, so the purpose of the shim is to determine the correct distance or offset between the reed head and the scale which is 0.5 millimeters plus or minus 0.2. So let's go ahead and check that out. First, we'll loosen the 6 millimeter reed head bracket screws. And then slide the shim between the reed head and the scale. Now, one trick to remember here is to leave a little bit of the shim hanging off to the side. So you can see here that the assembly is rocking back and forth just a little bit. So I'll readjust the grub screws. And basically what you want to do is to extend the grub screws until they just make contact with the side of your machine. And I'll try rocking it again, and that feels pretty solid. Okay, so I'll tighten everything back down. And what you're looking for at this point is that the shim is snug, but not absolutely pinned down tight between the reed head and the scale. In general, if you can hold the shim down tightly with your finger and move the reed head off of the shim, then your spacing is right on. If your reed head drags the shim and your finger pressure can't free the shim, you've probably got it a little bit too tight. Okay, so at this point, the scale and the reed head are both installed. Now, let's make one more final operational check. What we need to do is to run the cross slide through its full travel. Now, be especially careful as you approach the ends of the scale. We want to make sure the reed head doesn't bind or dig into the stainless steel cover. Remember to check all the way to both ends, full travel. And now for the last step, mounting the scale cover. Now here's the cover, and normally you would mount it above the scale directly to the machine like this. Well, we'd like to offer you an easier alternative. Let's take a close look at the ends of the scale. Okay, so here's a closer look, and we can see that each end cap has a threaded hole on the top side, which isn't really being used. What we suggest is to mount the cover directly to the top end of the scale. The advantage of doing it this way is that it means you have less holes to drill and tap into the side of your machine. So here's our cover, and to make this happen, I'm going to modify it a little bit. Let's take a look on the lathe. First, I'm going to shave off this top tab here because I don't need it anymore. Second, because we shortened the scale, I'm also going to shorten the length of the cover. And finally, the overhang here is a little bit too much, so I'm going to shorten this bottom overhang a little bit. All right, so we've completed our cover modifications, and here's the cover. Now, notice that I've taken this top tab off, I've reduced the length of the cover, and I've also reduced the overhang of the cover. And finally, I've drilled 2 holes in the top here so we could mount this directly to the end caps. Now, one last tip. The depth of the end cap side holes won't allow us to use the full length of the supplied cheese head screws. So you can either shorten them or use a different type of screw. Personally, I prefer to use a lower profile button head type screw like this one. So that's what I'm going to use. So next, let's install it. All right, so that completes the cross slide scale. Let's go ahead and move on to the installation of the carriage scale.